Hi, Jakob.
Hi.
Hey everyone.
Hi, Rob.
Aaron.
Hi.
Yeah, let's get started. So in the working group on Thursday, we presented the proposal. Matt had some feedback and you left a comment on the gist with some ideas. So yeah, maybe we should start by talking through that. I can share my screen. Yeah, Matt, do you want to maybe just walk through this a little bit for everyone?
Sure. So, yeah, the basic premise here is just like, like what I'm trying to avoid us losing in this proposal is essentially the, like, as much as possible, the WYSIWYG sort of nature of GraphQL or the response format. So like the fact that when you see a defer, you should be able to know like, okay, yeah, this is in some sense, this is a thing that that we're going to have to refer to later. And so in this iteration, we end up still with trees. The incremental response basically becomes a map. So you can quickly look up, oh, I have a defer 0, I have a defer 1. And only the defer 0 has not come back because it's not in the incremental payload yet. It's in none of the incremental payloads that we've received until later. But the first incremental payload has some, like it could have some shared payload as the server, like the current server executable design has it so that each time that there is a potentially shared deferred payload, that you basically split it into its own pointer. And like even in the current design, not this design, but like the one that Yakov has built and Yakov and Rob built, like we have these pointers, they're just sitting there as flattened lists, essentially, rather than as like they're flattened lists that contain a tree, but looking up, my real problem is like looking up, finding the exact item that corresponds to the place where I've deferred is difficult. And I think something along these lines where we could have some pointer, know where that pointer is, and then like have the incremental payload be a map of which pointers we have and what the subtree is, and potentially pointers inside of that map. That would allow like that would allow a pretty naive client algorithm of just like walk when you see the defer payload, see if it's in any of the incremental maps. If it is not, then like you're still waiting for it. Otherwise, it's there and like you can keep walking from that point. And I'm confident that this has problems. Like the proposal as presented, like with the underscore defer, with the 0, with like, I'm confident that there are issues that we would not want to ship it as is. But this is like, in my head, this is the like slight change to the response structure that I think would make it more clear for clients what is happening without actually changing the server execution at all.
Yeah, it makes sense. Just like to start with the low hanging fruit, this version injects some data into data.
Yeah, we could avoid that, I think, but that even Ivan during the working group was like, if we could somehow get the injected value in, that just, it simplifies so much downstream in terms of the response format. But if we can't, we can't. Yakov?
So I think it's true that if we embed the defer, the underscore defer in the data. Another downside is that a client would have to like walk the entire tree to find those, unless they, obviously they have knowledge of the individual operation and the schema, so they could have pre-knowledge. But just looking at the response, very, very naively, you would have to walk the payload to look for those. So I posted an idea maybe that might address some of your concerns in the Discord chat that I just dumped into this chat also, where basically I don't know if people basically there was a comment that I made for the completed array that we could also use for pending, meaning we could basically create like a separate tree of just the pending defers. We would still have to embed some special characters for the completed. We were talking about a plus sign, and for the pending, I used in the chat that I just dumped in. I used a minus sign because you could have a defer at some level, and then you could have some nested defers as well. But I don't know if you have time to take a look now, or I could walk everyone through it basically in terms of what that example would be. But it basically is a way to build up each payload from its components, and it has the downside of while it never repeats leaves, it certainly does repeat subpaths as well. And it has another little bit of a wrinkle in that the original data will get broken up into fragments as well.
Did your I think your example got cut off in the chat.
Looks like it.
Let me try to post it in again then.
Might have also been a pace limit in Zoom or something.
Whilst
Might be
you're
easier
doing that,
just to- yeah, sorry.
Matt, in your example, I'm just trying to read through it, make sense of it now. You've got the pending 0, 1, and then you've got incremental with the keys 1 and 2. Oh, I see the 2. Now I'm looking at Rob's screen, I can see it. It's the defer A that's embedded. Has a value of 2. Okay, no question. I think I figured it out.
Yeah, I mean,
So-
I haven't had a ton of time to think through it, but just like overall, like getting around the problem of injecting data, I feel like it would either be you somehow put that data in a parallel tree somewhere, or you have a new double under field that you could query. But I think the problem would be that when you have these overlapping fields, you would basically need to put that double under like everywhere, right? Because it's not necessarily going to line up with where the originally I was thinking you put that double under power like as a sibling to wherever you have a defer inlined, and then you could get what you need. But I think that it doesn't necessarily line up with where the defers are in the case of overlapping fields like this one here. Like
Yeah,
it does
Yeah,
here, but it doesn't have to.
right. Right. I agree here. So I've tried to keep the labels and whatever, but right, the double under defer A showing up twice is weird. I don't know how to get around that if we preserve the server only sends, like the server deduplicates portions of the response. But
So I mean,
Another
go ahead.
thought on this is I wonder if we're optimizing for the wrong thing, because with the flow of where you effectively just apply the append only patches, sure, there's mutation involved, but you're doing it once at reading from the network time, and then it is done. Whereas in this style, if you're, I mean, you could still do the same thing, but if you're encouraging clients to read from it this tree and build it up, each time a component renders or something, you're doing that work over and over and over again. And I think that that's not necessarily something we should encourage.
So redoing the work over and over and over again, that is the React model, right? Flow from the top. I mean, it's like React is smarter in that it does calculations of, oh, this subtree doesn't actually need to be re-rendered. The subtree actually is the exact same. But like at its core, it's just like start from the top, pass all the new props through and re-render and flow to the leaves basically every time. Like every time data updates, go to the top and re-render all the way through. And like that is actually our native clients. That is, so Relay doesn't really do that, but our native clients have that exact model where we only have a single subscription at the top. And even for defer and stream, every time that there's a new defer stream payload, it potentially causes a full new re-render. So,
and
that's
maybe reusing the immutable parts of that enables more caching. Okay, yeah, I see.
Exactly. Although our native clients have a bug where figuring out the local part is hard, which I want to fix. But like part of the reason why, like, if you have to continually mutate a store, that actually forces that from the top re-render every time, because it's the top level item that has the store, and like you don't know if you don't know whether your component is affected by that. Like you can only know whether your component is affected by a change to the overall response store by essentially walking the full response.
Okay, separate question. It looks to me like you could build these objects from the objects that were previously proposed by looking at the pending objects and applying, building the little inlines. So is this something that we really need to concern ourselves with in the spec and actually worry about putting these like dunder with colon fields in? Or is it something that the relatively naive client could do as a simple transform and then use from then onwards?
Yeah, the dunder fields I'm less concerned about. If anything, like, I guess the main point is that the incremental payloads should not be stored as a list, but rather as a map. And the reason for that is like if we assume that you're going to get a lot of incremental payloads, which maybe you will, maybe won't, like it's fine, especially for the spec, to have, essentially the like pending with the paths. Like I don't think you necessarily need the double underscore. That was just like, this provides a very concrete pointer into it. But I do think you probably, and I think I failed to add the pending payloads in the incremental responses that we would need if we didn't have the double underscores. But even the pending, like, okay, here are the two IDs that are pending. Here's their paths. And then in the second incremental response, we would still have a pending, oh, we wouldn't have a pending two. I guess we would actually have a potentially, if we didn't have the double underscores, we'd have a pending two, completed two. Right? Because you'd need to know pending this two has this path and it's been completed.
It's shifting the IDs from being like, this is the ID for that defer label path combo, like this specific defer, to referring to the incremental data itself. And so there could be more than one ID per deferred fragment.
Yeah. And the real tricky bit, I think, is figuring out, because I think the final response, if we don't have the double underscores, the final incremental payload also needs it doesn't necessarily need maybe pending is the wrong word, but like deferred pointers, where, right, it also needs a deferred pointer back to 2, even though 2 has already come. Like the final payload needs to say, hey, there is an at defer at this path, and that at defer actually points back to, or like there is a deferred payload at this path. And when you're looking up that deferred payload, you got to go back to the 2, because otherwise the fields aren't going to be there. Like you don't have access to the fields in this data payload. And that's the core like mental model that I'm trying to, I don't care necessarily about the double underscores or I want like the being able to point back and have multiple pointers pointing back at the same deferred payload.
Should we?
So if Rob, if you refresh on that gist, I think I hope there's a comment there now that has the full example. And I think it's basically along the lines of what you want. So basically we have the initial result is a little bit different because it's, but it's also separated into fragments that can then be reused, fragments of data. And this just demonstrates defer and not stream. I haven't thought too much about how stream would fit into it. But basically the idea is sort of, I think what Rob alluded to, we have IDs both for fragments and for the incremental results. And we give like all the information that we have, meaning as each we only give fragments as, you know, when an incremental result is completely completed, we only emit the fragments at that point. But once we do, we tell the client all the result IDs that it's eventually, we give a preview of like all the result IDs that this is assigned to. And that way they can keep track, you know, to only hold on to them for as long as necessary. And so for the first result, in this example, we have the common fields between the initial result is going to be fragment ID F0. And then F1 is that leaf I that only shows up in the initial result. And then we say that there's a pending, now we have a map. Here there's just one example, but in a more complicated example, you could have fields and then, you know, listed under that. And that minus says that, a minus says that you could, you know, we'll expect something, if there's something subtracted, I guess, from the end result. It's kind of the mental model, but that's the defer that's going to be showing up, and it's going to be called R1. And so then the next result that comes through, R1, says to reuse some of the fragments. You know, at the root, we're going to reuse F0, and then we have a new fragment F2 that is sent now, and then we have a new, you know, a new leaf F3 at that new leaf J. So I think, I mean, basically we're repeating some of the insertions, like F0 is repeated twice. So if someone doesn't have, meaning if you're just trying to update a store, then you could keep track. If you already inserted F0, you don't need to. Also, it's non-destructive. So if you wanted to, you could just, well, actually, no, it would be destructive at that point. So, if you're updating a store, you don't want to, if you inserted F0, it would rewrite what was already inserted under F1. So that would be dangerous. So you would only be able to insert the first time. And that would be like a different algorithm, but it has all the information, additional information that allows you to have different client algorithms. I'm sorry, I didn't see, Matt, what you wrote over there, so I commented in the Discord. I could have commented earlier, but I guess I was still working it out, to be honest.
Yeah, I don't. Why is I being put into this F1 in this example?
So I is being separated out from F1 because we want to describe that the second deferred payload doesn't have I, it doesn't have what's in F1, doesn't have I, but it has all of F0.
Oh, I
Um,
see.
So that's
Yeah.
kind of annoying. We didn't need to do that with the pure insert only model, but now we do.
So I don't think. Yeah, that feels like it will almost immediately cause yeah, maybe I'm getting hung up on fragment ID because they're not actually, it's like compiled out, it's like compiler fragments.
Right. In the algorithm, I was initially calling them fragments on the execution side, and Rob pointed out that's a terrible name. So on the execution side, they're called like group field sets, or so
Okay.
they're not
Okay.
really fragments. And we should probably rename that here also, but I was just whipping this up.
Yeah, that makes sense. Okay.
And the idea would be that also when the deferred payloads come in, you can read from that map exactly what's in it. You don't get any excess fields. There's nothing in that map that was like already delivered belonging to a different fragment. And so you have sort of, local local completeness and so local exactness. If you wanted to, you could include I in F0 and then it would be like there would be some excess data in there.
just to like take a step back, do we all agree that like we shouldn't inject additional like metadata fields into any kind of like data response? I think you definitely can't do a double underscore because that could be a valid field. You are allowed to alias any. You can't have a double underscore as part of like a regular field, but you can alias something to it. And then even anything else gets tricky when there are JSON scalars that exist in the wild. So like you could see like basically anything.
So just to respond to that, Rob, I think that there should be an extremely high barrier for entry for adding keys inline, but I don't think that we should entirely rule it out. Secondly, we can use external data. So we already have this pending field. If the pending field references where these special inline keys are, then they won't, or they can be disambiguated against confusion with custom scalars. And further than that, like I just said in the chat, I think it's essential that if we were to put these little placeholder keys in line, we should also reference them in an external array to save clients from having to scan through every single key deeply nested in an incoming field in order to process it. So I think that by having this necessary pending, we can not worry about the custom scalars issue. So I don't see there being a very significant, no, I would rather that there wasn't these inline keys, but I am open to it with these other caveats in place.
I
Yeah,
agree with
that's
that.
fair. I think I agree with that. Yeah.
Yeah, so when you know, in the example that I'm showing over here, there are never any like double underscores or pluses or minuses inside the data that's inside fragments. There is a field called data inside completed, but those are just kind of that's like a subpath map towards actual data. It should never have any leaves in it, if I have that correct.
Is
And
this
so
this one I have highlighted here where
What
there's
about the one below that, on the line below that?
Yeah.
correct, those special characters inside that data, there should never be any leaves. Meaning we're talking about where to insert, you know, fragments or for group field sets, but we're always inserting into an object field. So there are never any, you know, leaves over there. And so you should never get any confusion with custom scalars.
The issue there, Yakov, is that the client doesn't necessarily know that C.F is a leaf. Like it doesn't necessarily know the schema.
No, but because of our algorithm, it will know that leaves will never show up in there. Meaning that's a map of where to insert the fragments. Fragments contain leaves, but this map will never have a leaf in it.
this is not actually data. That's what you're
Well,
saying. It's yeah.
Essentially, yeah. I mean, I think it makes naturally. I would call it data because it's you know, it's going to be the data after you follow all the insertions, but it's not quite data. Maybe a better name for that also. Probably well, once we're through with this, we'll have a better name for all of these fields. But I think the structure, hopefully, might point us in the right direction.
Just to make sure that I understand what you're saying, Yakov, are you saying that you would always have that field CF in like the original fragments entry? So that's how the client knows it's an object because it was given it without any of the pluses in line, and then the pluses come later.
Yeah, well, a deferred result. Once we have a deferred result, all of the leaves will show up. Meaning that all these paths, essentially that are in data, is really a tree of IDs and subpaths from the other proposal, meaning that make up this completed. And and they're all basically like pointers back to the individual incremental items from our old proposal. And so just like in, the paths to an incremental payload when the subpaths never had any leaves in it, that it just, so too, all this, the entries in this map will never have any leaves in it.
Right. So this data that Rob's got highlight is more template. It's more a template.
Yes.
Got it. Okay, thank you.
Which is not to say there's not a better, a different, better solution, but it's only to say that I agree with what you said, Benji, and what you said, Rob, that we can insert it into actual data. That's all. There could be a better solution still.
So I just wanted to mention another couple of the things that I've written into the text chat. One of them is that the order of the incremental payloads is significant, which is why it's a list currently. But if we do it as an object, that's still fine with the pointers in place, because hopefully we would ensure that the pointers resolve in the right order. But if not, the client could detect that. And another advantage, I think, that would apply to Matt's proposal is that we would be able to restore the ordered fields. So I was saying in the working group on Thursday that one issue with all the stream and deferred proposals at the moment is that if you have a selection set A, B, C, where the B is deferred, then at the moment it would always come out as A, C, and then the B, because that comes later. And things get more complicated when you add more deferred things, because they, depending on the order in which they complete, the field order would not be maintained, which is quite a breach from what we currently have in the spec itself, where we guarantee the order of the fields. So having these inline placeholders be able to ensure that once you've stitched everything back together again, the fields are still in the same order, that's actually quite a neat thing, and it's something definitely in its favor.
All right. I think I have an example where we could get away without using the double underscores. Let me just post that in the gist in a sec. Something closer to that. I think that's mostly right. So I just posted in the gist where basically, oh shoot, I messed that up. Let me edit. I kept in a double underscore that doesn't need to be there. Yeah. But yeah, basically the idea here is like, yes, we keep the paths for the defer, which maybe a tricky bit is maybe I'm not sure whether the defers payload, like saying what is deferred, should be a map on ID or inverted. It probably needs to be inverted actually, where the path is the lookup value. Now that I think about it, because that's what you're going to want to, right? You're going to want to walk to where the actual path is from this point in the data. Yeah, so the defers might have to become a tree, and I think that gets pretty similar to Yakov's proposal without changing the structure of like adding selection set fragments specifically. I don't think we need those. But yeah, basically each incremental payload that has its own pointer could itself have inner defers that it needs to like, oh, this is the tree that we are looking for deferred payloads. And that does introduce a second tree to walk, but it at least is a very clear like tree path. And yeah, now that I'm actually looking at it, I do think
Could this
having-
one be inside of this zero object?
Yeah, or inside of the 1 and inside of the 0, both of them are pointing back at 2, but you'll notice that the path to 2 is different depending on which deferred payload you're in. Or which incremental payload you're in, right? Because from
the path
0,
is relative to where
right,
you are here.
exactly. Yeah.
And you're thinking that this gets turned into a tree, so like an object with A, B, and then the label and ID as an object inside of that.
yeah,
Something like that, yeah.
I would edit the gist, and I can repose or whatever, but yeah, I'd edit the gist to
So it's actually very similar. It's just that instead of like walking through this tree and finding those double unders, you're walking through both at the same time. Right.
Yeah. Or you do have to preserve a path as you're walking. And if you, as the client, know, oh, okay, I need to see, is this like, I know that there's a defer here. Do I have the data for it? Okay, you walk through and you can say, okay, these are the, this is the defer at this point, given this path. This is, and like, it's still a linear walk, but it's only a linear walk. So long as you know the path that you're walking, you only have to look up n deep levels. Whereas with the list path, you basically need to, for each item in the list, you need to walk through the entire structure.
Yeah, should we edit this now just to
You can do something.
I can do it just to,
Yeah, I got it.
we can see if I'm understanding what you're saying.
Oh, yeah. Yep. Yeah,
Like this,
exactly.
and then we also
Yeah.
have one at the root.
What's the property name for that?
Yeah, you'd need to have something that's not allowed to be a field name. So for example, Yakov's plus would work.
Yeah, something plus an underscore, and possibly
Should you put something inside of here?
It could even, because it's the top level selection set, it could be a list. Like the defers probably needs to be a list. And then it's like a list of objects that all start at the top level.
Oh, right, yeah.
Right, because that's like independent paths from the top level. So it's not like, it's basically the selection set at the point that you're, the set of deferred fields at the selection set that is being deferred. And yeah, that one, A is not a list, A is an object. Yeah.
A is inside an object.
Yeah, because that's like right? Yeah, because yeah, basically this is A is the tree. Yeah, sorry, this probably needs some smithing. It could be a list, it could be we just use underscore or like a minus or plus or whatever for items that are at the top level, probably plus, probably that makes sense. Or something, or just like empty, an empty key or something.
Yeah, and it would be good to think about if this was not just for defers and also could tell you that for there you're waiting for stream items.
Yeah.
Yeah, let me just cancel this. But
Yeah.
but yeah, I think I don't think we're gonna come up with like the right solution in this call, but I think all of us can spend a few minutes in the next week or two and like come up with iterations, and we could keep iterating.
Yeah, exactly.
Yeah.
Yeah, but is there any like, yeah, I don't know, any initial reactions, negative, especially negative, like this feels worse in some way, some clear way.
I do like this one. I think that because it's basically the same as what we have. It's just really just changing pending in a small way, putting it inside of the incrementals. So it's more of a pointer, having it as a tree so you can traverse it better. I mean, I do think that just like there's more human overhead. So like looking at for all these examples, like looking at it and understanding what's going on. But that's probably fine if we have performance wins in the client. Yeah, that's my thoughts right now.
I'd like to see the final payloads before passing a judgment, because at the moment I'm a little bit lost.
So for
Yeah.
my example, I if you reload it, I refreshed it, I renamed fragments to segments, which sounds weird, but is at least different. And then I changed data to just the word use, and the idea is that you're gonna to map to how you use those segments. So, and I think it gets at basically, it has more changes, obviously, but I think it gets at what you're, you know, I mean, I guess it shows that, you know, we can do this, and that what some of the downsides are. Some of the downsides are that we won't repeat sending a segment or, you know, or a leaf. But we will repeat, we will repeat that, you know, that we're using it. I also added, you know, sort of exactness, you know, so that they're never, you can never, you can tell that, you know, you'll never by accident reference a field that was previously sent just because it was previously sent. It, you can tell, you know, which fragment it belongs to, but that, you know, Matt, as you pointed out, results in, you know, more of these segments, which is possibly not desirable. So those are two of the downsides. Overall, like, I think I get why, you know, I've just been trying to think about it more. I get why, you know, you want a, you know, immutable version of this. I think that's the, you know, I sort of have been coming around to that. I'm just sort of wondering if, you know, we can't, you know, shim something, yeah, on top of what we already have. But I'm okay, you know, I think it's like sort of how to package the data. But basically, you know, I'm okay with whichever the group decides makes sense for what that's worth.
Yeah, and I do think there's value in just like readability. So if all of these, like, okay, we can have direct pointers, if all of these end up resulting in, you know, huge payload bloat, huge readability issues compared to just like having the list and having the pending and having like, because like because the spec response format is really designed to be readable and like grokkable. Like even like our intro GraphQL course at Meta has like, oh, you want JSON, but you don't know the values. What does that mean? That means you write GraphQL like the JSON and it's in that format. And like, the closer we can be to a format that is grokkable, even if it means either more complex algorithms or like, that's probably fine. If like you have a client that needs a lot of performance, yeah, you'd shim something underneath. Like if it means that we are getting a substantially like more parsable, more readable format. But I wasn't confident that the immutable format was necessarily less readable than the mutable one, basically.
Yeah, I think we should iterate on these and see where we end up.
And I guess
in a few weeks.
basically, we should always feel free to pop the stack. Like every time we adding some complexity here, we're like trying to resolve some complexity, some ambiguity, some, and it's okay to say we went down that path and it doesn't feel right. So we're popping and like, we're just not going to try to solve it that way. And I would even encourage like, if like from my perspective, if we can get the readability, even with like response format duplication, like I've always been more or less like, it's okay to have large responses if that means that they're very readable, where the client and server could opt into a more compact format if they really need those like strong performance wins. But the spec is about explaining like what needs to be possible. But
Yeah, makes sense. Anything else we should talk about today?
Seems like we're good.
Yeah, I'm actually not going to be able to make next Monday. So we should cancel it or
yeah, that sounds
Yeah,
probably
we can
right.
cancel it. Yeah, skip next week.
yeah.
Awesome. Sounds good. And will do. I'll update the invite.
And I know that Yakov has been working on his implementation of what's described at the top of that gist. And I will spend some more time reviewing it. And I think that see like how much of that we can get merged into main of GraphQL.js, because it's only an improvement over what's there now and is closer to the direction we're heading. So I'm going to try to spend some time reviewing it.
Sounds great.
Awesome.
All right. Well, great chatting with y'all. Benji, enjoy the rest of your party day off.
Thanks.
Oh, sounds like a big party. All right. Take care, all. Talk again soon.
Goodbye, guys.
Bye.
Cheers, everyone. Bye.